Okay, so we are live. Let me just check on the YouTube to make sure we are live. All right, we are live.
Yep.
Hi everyone, welcome to Virtual Muleys. I think I'm echoing. Yeah, welcome to Virtual Muleys Online Meetup 21. Tough times are around, so I just hope you all are safe wherever you are. You are doing well, so take care of yourself first. With that said, can someone just confirm on the chat that you guys can hear and see it well? I think that will help me to know. And I guess, yeah, yes, okay, so they can hear it. That's good. Before we start with our regular session, I just have a quick announcements for today. We have MuleSoft Connect coming up. You all know this year it has gone digital, so and it's free for everyone, right? So the first event is for the MuleSoft Connect Americas, which is on 20th of May. It's free, accessible from everywhere. So let me just share some slides first with you guys. And okay, so that's the one, MuleSoft Connect Digital Live Virtual Experience. It's 20th May, which is coming up. You can go to connect.mulesoft.com to register yourself. Uh, the next one, during that Connect session, we do have some community events. So once you go in on that site, you will see the agenda and what are those time slots. The two to mention is are two sessions. One by Veera, uh, which is for dynamic data view for secure access, right? So that's a good session. And second one from our MuleSoft ambassador Joshua. You might have seen a lot of data view posts from him. So I would be surprised if anyone doesn't know about him, but it will be a great opportunity to listen from him for what he thinks about data weave and his good knowledge. So I would definitely suggest you guys to tune in for that. There is a time 20th May 12:30 to 2:30 PST. So if you haven't registered yet, go ahead and please register for that so you don't miss out. With that said, I think it's time for our today's session. So today we have Pradeep Nehe. He's a senior technical architect from with Salesforce/MuleSoft. He's gonna take us over PubSub integration with MuleSoft using GCP platform. So I think that should be fine. More time for you, Pradeep. So I'll stop it. One quick last thing is, if someone is joining for the first time on this session, there is a YouTube chat on the right side of your screen. So feel free to drop your questions, comments, anything on there. At the end of the session, I will ask all those questions to Pradeep and we will try to cover as much as we can. With that said, I will stop my screen share, Pradeep, and I will hand it over to you. Pradeep, it's yours.
Okay. Thank you, Malik.
Sorry, sorry. One quick, just to finish up that connect part, Dima. No, you don't have to register. I think for a specific session, once you register for connect, you should be able to build your agenda on there and like choose which session you want to see. So I would say just go on that site connect.mulesoft.com, register yourself, and browse it. Sorry, Pradeep, yours. Go ahead, please.
Okay. Thank you, Malik. Uh, uh, hi everyone. My name is Pradeep Nehe. If you can hear me okay, I can just start the session. Good morning to the folks from the West Coast. Good afternoon to everyone from the East Coast, and good evening to the folks from the EMEA and IPAC. I hope that everyone is doing well in the current situations. So today I'm going to talk about GCP PubSub and how do we integrate it with the MuleSoft. So I hope that you will find it helpful. So let's move to safe harbor statement. This gives us confidentiality and proprietary of MuleSoft. So I'll just pause here for a couple of seconds so that you can just go read. So I hope that, okay, you got a chance to read through it. So let's move on to next slide. So this is about me. So I have been with MuleSoft for last 4 years, and I have 20 plus years of experience in integration, design, and development operations. So I worked with multiple business verticals, include financial, and then some of the clients are Bank of America, Wells Fargo. I also worked with insurance company that includes the travelers, AIG, and then some of the retail companies as well. So as far as integration technology is concerned, I worked on various platforms. Obviously, that includes MuleSoft having the multiple deployment model, on-prem and then hybrid and RTF. I also worked on the IBM product, like process servers for the integrations, and then some of the radar product, including the Camel and JBoss. So that's about me. So with this, let's get started with our today's agenda. So what is there on the today's agenda? What we're going to talk about? So we are going to talk about resilient and reliable architecture. So what does it mean and why it is important, right? We'll talk about that. Then we can talk about how to handle the failure in the system, because any system, any software system, failure is an inherent to the software, right? So any piece can fail due to various reasons. So we will talk about that. uh, Later on we can go over that, at least once message delivery. So many times there are use cases where we need to make sure that, okay, we can deliver a message at least once. So we'll talk about that use case, and then we will move on to the Google Cloud Platform PubSub module, and how do we use MuleSoft to integrate with that. So that will be the next topic, and then we will segue into demo, and then after that we will have the Q&A session. So I would request everyone to hold your question till last, and then you can ask during the last 15 minutes then. So with that, let's move on about to resilient architecture. So resiliency is also called as recoverability, right? And this resilience architectures deal with the failure through high availability and the fault tolerance. So let's talk about what are the important concepts in the resilience architecture, right? So what is a well-defined architecture? So this is one of the characteristics of this resilience architecture. So when we define an architecture that has 5 characteristics, it need to be resilience, it need to be high performant, it need to be efficient, it need to be secure, and it need to be excellence in operation. So these are kind of non-functional requirement we need to consider about. The next one is ability to adopt the changing condition, right? So what are the changing condition for the software system? And it could happen that, okay, at many concurrent user it trying to access system at a given time, right? And that will put our system into different condition. Or it could be happen that, okay, you have the system during the holiday season and they're trying to access system, so there is more workload on the system. So that could be the another changing condition for your system. So next one is about how your system can quickly maintain and regain the functionality, right? This is very critical when you are developing your resilient architecture, that if system could fail, but it should not impact your end user. It should have the ability to come out of that failure very fast. So next one is recover quickly from failure, right? So this is what I was talking about, that, okay, even the system fails, it should recover it on its own in few cases, right? There should not be any data loss, and the customer did not have to either enter the data, or if it is another system calling your system, they should not to retry that their call. So that's about the recovery of your system. Then availability, right? So any system we develop, we try to make sure that okay, our system is up and running for most of the time. So this availability is directly related to the customer's SLA. So when you talk to customer that okay, my system has 99.9% SLA, what does that mean, right? How do we measure this availability? So basically, this is the formula normally people use to find out what is availability of my system. This is uptime, right? Uptime is about the mean time between the failure. And then there is a downtime. Downtime is a mean time to repair the failure. So one is about the failure and how much time it takes to fail to overcome that failure. So that's how we can calculate the availability of my system. And definitely everyone, right, try to make sure that okay, my system is available most of the time, and we can have this SLA of maybe 99 or 99.9%. So how do we achieve that, right? So these are all the characteristics of any architecture. So let's take a hypothetical example, right? Suppose I have a retail customer, and then they want to develop a system, right, which is a resilient system, and they need to have all these characteristics in their system, right? I presume that okay, you all have the MuleSoft background and know that okay, API-led architectural style. So let's take a look at this example, right? So this is a layered approach, right? This is basically an order fulfillment business requirement system, right? So it looks good. If you take a look at this architecture, you see that okay, there are multiple layers are there. You have a distribution of responsibility as well. So everything looks good. So what is the issue in this system, right? So if you look at the system, do you think that okay, this system as you see here, is it resilient? Can this software meet a high SLA? So is this software is a fault tolerance, or this architecture is fault tolerance and performant, right? So I'll give the couple of seconds here. I'll take a pause and you look at this software and see that, okay, does it meet all my requirement? Okay, I think that okay, here enough time to go over and then analyze it. What does it match, or does it have this all the characteristics we talked about? Let's go to the failure point and how to address it, right? So let's me move on to next slide. So this is the same picture you will see here on the right hand side. This is the existing system. This is the existing architecture of our application, which is order fulfillment system. And let's go over one by one that what are the concerns and how do we handle those concerns. First is decoupling, right? So if you see here, we have the layered approach, right? This make a system very this makes a system where the component have little knowledge or no knowledge about the other component, right? So each component can behave on their own. So decoupling has few advantages. Let's see that okay, how do decoupling the system? What are the advantages we are getting out of the system? The first is the high throughput of the service. So how does this helps to give me high throughput, right? So the by finding any bottleneck in the application and then designing the services using the microservice based approach, we can scale up and scale down that particular component, and that's how we can make sure that okay, my system can be delivering the high throughput during the operation. Next is easier to manage on adding feature. So having the decoupled, it helps me to add new features. In this scenario, if you look at this order status or maybe order fulfillments, if I wanted to tweak any of the service or add more functionality, independently, I can go ahead and add those features without having any impact on any other component. So, and also it gives me ability to separation of concerns in my application and reuse, right? So in order management system, order status is an one API, and it has all the logic pertaining to the order status. So it has taken care of my separation of concerns, and at the same time I have the other APIs. If you look at that shipment and then the order management system, those can be reused in this case. So that way, deep coupling can help me to make sure that, okay, my system can come out of that failure very fast. So let's look at the next point, right? So load balancers. So we can add a load balancer to avoid the failure in a node, because most of the system, most of the application, when you deploy it on the multiple node, and having the load balancer in front of that node, it helps us to avoid a failure at a single point then, because any node got failed, so load balancer will detect it and it will pass the traffic to next available node. So that way load balancer can help us. We can also have the load balancer at your experience layer, wherein it could give you the same advantage of having shielding the nodes and then giving that failover. But at the same time, if there's a requirement wherein you need to have the two-way SSL need to be implemented, so that way it can help you to add this SSL certificate, so that you make sure that, okay, you see the security is imposed uh, at the experience layer. So next talk about the auto scaling, right? So as we discussed before that, okay, suppose my order fulfillment system, and then at any given time, if I have much more load, or I have more concurrent user, and I see that, okay, my particular system has a bottleneck, right? Because it won't perform because of certain limitation. So at that time, this auto scaling of any particular node would help me to mitigate that problem, and make sure that, okay, my system is performant during that period as well. So next we talk about the clustering. So clustering is the same, similar to your nodes. Once you have auto scaling, you need to have those nodes to be clustered. So even though one node fails, or if you have this event driven architecture, in that case, that whatever the leftover work can be passed on to your other node, and then your other node can take over that job and fulfill that job. So that way, it's your failure, your system is recovering from your failure very fast then. So another consideration you can do here is about adding the caching as well. So I'll not talk much about this one, because everybody knows that, okay, what caching is. It's basically make certain data available in case some system fails momentarily. uh, and then it also helps us to maintain the statelessness of the architecture, right? Because must have seen that, okay, if there are multiple nodes are there, and you want to make sure that, okay, whatever the state is maintained on the server side, it is maintained properly. So many times you need to use a sticky session in your load balancer, so that the request coming from the same user get forwarded to the same node. But having the clustering and caching mechanism, you don't have that limitation. So you can leverage that caching to make sure that, okay, you have stateless architecture, and which is scalable as well. Next is talk about the data replication, right? This is also very important point, that, okay, when you wanted to have a system where some failure occurs, and then you want to switch over to another the service, but there is chances that, okay, if that system may not be in sync up with your latest system then, right? So that's where the data replication is important aspect. So that you make sure that, okay, your data is replicated very frequently. Many times it happens that, okay, this data is used for multiple use cases, maybe for your data analysis or your data warehouse, And at that point of time, you don't want to burden your real-time system to fetch those data. Then with the data replication, you have the another system which is similar data is there, and your all the backends tool, they can work on those replicated system. And then the another point is domain routing, right? Think of your system, right? Suppose even if it is cloud hub, or if even if you have your own data center, and then many applications would have this disaster recovery, right? Because if something goes catastrophically goes wrong, how do we recover from that scenario? That's where you can have kind of your domain routing, wherein your DNS provider will have some kind of SLA or some weighted routing, where it has a sufficient intelligence that, okay, when something is fail on one domain, it can switch traffic to your different domain. So these are the couple of ways you can handle this failure of system and make sure that your system is resilient. So let's see that, okay, how does it features, right? So I talked about couple of concept, how do we add into our existing architecture and make sure that, okay, we have all those capability. So let's take look at experience layer, right? As experience layer, what we did that we have added the load balancer. If you look at this load balancer at the front end, that will kind of gives me the ability to have the SSL with my client, and as well as it can route the traffic across the node. So so second part, if you see that, okay, here I'm doing the auto scaling. This instance, in case provider need a more power, so I can horizontally scale it and add more power here and give that auto scaling. And at the same time, I can put this in the cluster as well to give my the performance and throughput, better throughput. And then you see here, I have added the cache. As I was talking about, in some case, suppose your system is failure, right? How do I recover out of that? So in some cases, you have some static data, static content, so you can use your cache it and then serve it to your client. So the client doesn't know about the failure in your backend system, but you need to be mindful about setting this time to live, right? How frequently you want to update your cache. So that's we have implemented here. Same thing here in process layer. I talked about the cache, you can have it, and then we can have the data replications. So these are the measures we can put in to make sure that, okay, my system is resilience. Uh, and then another aspect I would like to highlight here, if you look at this one, right, I have the load balancer kind of in front of each layer. This is the kind of recommended practice that, okay, having your system separated by the load balancer. That's obvious reason that, okay, it balances the load and gives you ability to talk to only the one endpoint. So this is how our architecture will look like when we introduce all these measures. So let's go back, right? So there is another topic we talked about, that you have the use case and you want to make sure that, okay, you want to at least deliver your message once. So here I'm going to, there are multiple systems we can do that, but in this particular session, I'm going to talk about GCP PubSub, because I was working on one of the use case, and then for some obvious reason, that customer wanted to use GCP PubSub for particular this use case. So if you look at here, right, so what is the use case here? So once the order comes for order fulfillment, I have used the GCP over here. GCP pops up, and then once the order comes, it has to go to the Salesforce instance, it has to go to the order management, and then it need to do my payment processing, and as well as my third party supplier, it need to update the what is the exact order. So that's purpose I have introduced the GCP over here. And then as GCP out of the box, it makes sure that, okay, it will deliver the message only once. That's the guarantee. And then having the GCP here is another advantage. Is now, since this is the event-based approach, I can add my services later on as well. So what does that mean? That okay, it's tomorrow there is a requirement that okay, I need to send an email notification as well. So if you see this dotted line, I can add this system without any change, right? Just what I have to do, I have to go add a subscriber to the subscription, and then my system is there. So when we talk about excellence of operation, that's how we achieve it without making much changes to the existing system. We can plug in the new applications, and it becomes functional. So I talked about this at least once message delivery, right? So there, this system doesn't guarantee you that okay, there would not be duplicate messages. So it could happen that okay, there could be duplicate messages, but there are some other solutions which we can use, like Apache Beam programming model, right? That's the one of the other solutions we can use to make sure that okay, I'm not processing duplicate. Or suppose in case there are use cases that okay, that says I wanted to make sure that okay, my messages are consumed in a sequence, right? They don't want that out of sequence. I can give you the very small use case in this scenario that suppose you have the order processing, and you go and then put your order, and then later on you change your mind and you want to do add a change in your order or remove any order, right? So there will be another order, the same order but different version. Then you go and again add one or two atom in the order. So that is again the same order with a different version. So now you have one, two, three versions, but those have different information. So when you process those orders, you need to make sure that okay, you kind of process first and then second and then third. You have to have the sequence. So how do we maintain that, right? So there is another model for that, where your publisher can add a sequence token in the message, and then your subscriber can use that sequence token to make sure that okay, the order is maintained here. So let's talk about the GCP right now. I'll just give you a little bit overview. What is the GCP, and then what are the capabilities and features are available in the GCPs. So basically, GCP is an asynchronous messaging service, uh, and it basically is a decoupling service, right? It decouples your applications. It doesn't Your producer doesn't know about your subscriber, and that way they can communicate with each other without knowing each other. Then this also has the capability to have the durable message stores, so that even though your consumer is not online, it makes sure that okay, your message will be stored and it will be delivered at a later point of time. And at the same time we can ensure that this message is there. In some cases you have the requirement that okay, you want to make sure you encrypt your message, so it gives the capability to use inbuilt encryption, or you can define your own algorithm and then do the encryption. It also has the capability to real-time message delivery using high availability. Uh, it has got two models. One is the push, another one is pull APIs. Uh, since this is HTTP based, this makes sure that okay, it is secure. And then because of the GCP offering, it is cloud based. It makes sure that okay, this is a cluster and highly available instance, so you get the high availability as well. Regarding the use cases about pull and push, depending upon use case, you can decide what you want to use. Most of the time, the pull APIs is used where you have very large volume, wherein probably you wanted to process probably thousands, hundreds of message in probably 1 second or something. So you can use this one, or wherever you require a high throughput, you can use your pool API. And for obvious reason that, okay, if you doesn't have SSL certificate and all these things, you cannot use your push API, but you got to use your pool API because of some technical limitation. So that's where you use your pool API. And for push API, normal use case would be you have your webhook, and you want get the message from multiple source, where that's one example. Or it may happen that you don't, because you don't have the library for supporting this pool API, right? Because when you have the pool API, so in that case you need to have some kind of libraries for that particular language, and if it is not available, then you need to go for the push API. So those are a couple of use cases for those methodologies. Then performance at scales I talk about, because of the offering and clustering, it gives the performance. So I will also go over some of the key components when we talk about any PubSub. Uh, I presume that, okay, most of you are familiar with the JMS concepts. You know what is topic, what is queue. So those are the similar concept here. The topic is a source where the messages are sent by the publisher. Here we have the one more layer here is a subscription. That it is also a resource which subscribe the message from a single specific topic. So this is very important, right? There is a one-to-one relation between topic and subscriptions. And then you have the subscriber. So a subscriber is again another resource which subscribe to a subscription. And then you have the publisher. Publisher is the one who publishes the message on the topic. And then important part is your message, right? So you have to have the message, and it need to be a combination of data and your attributes. And then on the top you can have this, in the message attribute you can have this your metadata for the message, which is kind of key value for us. So next, let's see that, okay, what are different type of relationship exist in the PubSub, right? What are the use case you can use it for? So let's look at this fan in, fan out, and many to many relationship. So what is the fan in, right? In the fan in, what happens that, okay, you have multiple publishers, and they publish the message, and you have only one subscriber. So in this case, if you see that, okay, the publisher one publishes the message one, it goes to topic A, and then there is a subscription XA, which is having the one-to-one relation with that your topic A. And then your subscription XA has the message which is subscribed by your subscriber. So in this model, if you see that, okay, the one subscriber can get message from multiple sources. So this is the fan in. Then there is this PubSub also support for fan out. In case of fan out, you are having the one message is delivered to multiple subscribers. So message 3 is put on the topic C, and then you have again two subscriber, and then this message is consumed by subscriber Y, and this message is consumed by subscriber Z. So this is where you get a fan out then, and then you can have the many to many relationship as well. So these are the relationship possible using the PubSub. So let's see that, okay, how we can use the PubSub as a load balancer as well. Because we saw that, okay, we have the load balancer in front of many layer, but if you have the PubSub model and I'm trying to pull the message from my PubSub, how do I make sure that, okay, I can get that throughput, right? Because we talked about load balancer, it can give you high availability, and then it can come help us to come out of the failure as well, because it has the knowledge of which node is working, which is not. Similar way, we can use this PubSub as a load balancer as well. So if you look at this example, right, so I have the publisher A and publisher B. They are putting the message on the same topic, and then it goes to, I have two subscriber now, subscriber 1 and subscriber 2. So in this case, subscriber 3 is getting all my messages, A and B both. But in case of subscriber one, so I have for in case of subscription one, I have two subscriber, one and two. So what is going to happen here? This message would be load balanced, right? It will be processed faster. So as a message comes, it will be delivered immediately and it will be removed. And then again, second message will be given to subscriber two. So that way, it can act as a load balancer, and at the same time, it can produce the throughput as well, because you're consuming the message very fast, right? Because once the message is given, one message is given to subscriber one, it will start producing. At the same time, the second message is given to subscriber two. So that's how we can use this PubSub as a load balancer as well. And so let's look at a little bit into the how the message flows in the PubSub, right? So this is when you have the HTTP, you need to call this HTTP endpoints. This is very standard endpoint for HTTP for the Google PubSub. But let's look at that how the message get processed, right? So when the publisher put the message on the topic, first thing happened that okay, this message goes to the your storage and it is written in the storage, and then only it gives the acknowledgement to the publisher that okay, it receives the message then. So that is kind of 202. So now we have the message, and then you have the subscribers here. So assume a case that okay, where there is no subscriber and I got the message and I put it in the storage. What happened that we have subscriber added later on. So in that case, the subscriber will not get any message. So in short, when you put a message on the queue, whatever the subscriber are subscribing to the queue at that time, only they will get the messages. So in this case, I have this subscriber already existing. So what happened? The subscription, it goes and takes the message, and then subscription has ability to push or pull that message to a subscriber. So subscriber gets the message and it sends an acknowledgement to the subscription, and that's where this message get deleted from the message store. And that is how it ensures that okay, at least we have delivered that message to the subscriber at least for once. So this is how it makes sure that this is how it makes sure that okay, the message is delivered once by publisher. So we talked about the publishers. Let's see that okay, what are the limitations, right? So in which case and then what are the limitations so when we try to use Google PubSub? So here, if you look at that, okay, when you use the JSON or REST, your message has to be basics about encoded. The next one is about the size of the payload. What we can have message less than 10 MB only, and that is after encoding. Second, other one is your message payload must not be empty. It has to have some information. And then the third one is if there is no subscription attached when before you put the message, then that subscription would not get that message. So those are a couple of limitations about Google PubSub. And this is about single delivery. It may happen that okay, the message might get sometimes deliver more than once. Then I talk about how to handle that situation. What are different the ways you can handle that situation then. So let's move on to our the suppose we wanted to implement this one, right? Now we know what is GCP. We wanted to configure that Google PubSub inside the GCP, and then wanted to integrate with MuleSoft. So what we need, right? So first thing, we need to go and need to create a project inside the GCP. This is a very unique identifier for the project ID, which we'll need when we try to communicate with that PubSub. Second thing, we need to create a topic. You can go ahead and create a topic. This is the example. When you create any topic, it will prefix with the whatever the project name. In this case, project. This is my probably the project ID, as we talked before. This IDs get generated, and then since it is topic, it's topic, and this is the my name of the topic. Next thing I need to do is to create a subscription for this topic. If you look at the subscription, it will also have this unique ID. And while I'm defining subscription, it asks me delivery type, whether it need to be push or pull delivery type, and I can configure depending upon what type it is. The next thing I need to do is add a role, because whenever we have a subscription topic, so we need to enforce a policy that who can and who cannot access those queues. So that's where the member and role comes in picture. There are pre-existing roles are there. We need to make sure that okay, we make a member and attach that member to those roles, and then those roles are attached to this topic and subscriptions. So, and then other part we need to take care is we need to create a service account, because in this case member is not a person, it's going to be a system which is going to make a call. So we need to make sure that okay, we have the service account key, it is generated for your organization. And that service account key also includes your public and private key to make sure that okay, the communication between your system and GCP is secure. So with that's it. I think that okay, I covered a lot here. We go to the demo. Before we go to the demo, let me just show you some of the things what we did in Google Cloud. So if you look at here, I will really quickly browse through this one. If you look at, I just wanted to show you the ID. So this is the ID has been created. Once you go and create a project, you'll get an ID. This is the project, and if you go to the Google the sidebar, then you can go to your PubSub model when you want to do create. Yeah, here you go to the PubSub. You wanted to create a key topic, so go and create a topic. So this is what I talked about. For encryption, you can have your Google managed key or your custom key. I already created one, so I'm not going to create over here right now. Once your topic is created, the next part is you go and you have created subscription. So subscription, there are, as I mentioned that, okay, you need to have to mention a delivery type. Once you say pull, you don't have to do anything, but if you select push, you need to give your endpoint URL. And then there is another method that, okay, it uses JWT token to make sure that okay, you are authorized, and then you can process that request then. So there's a different mechanism for that. You can also define that subscription expiry, wherein you can have the never expiring, or you can define in the days, so that once that time limit reaches, then it will stop this subscription. The another good feature is about acknowledgement of deadlines. So what happens there, right? We looked at the chart that okay, how the message flows. So once my subscriber sends a message to a subscriber, and then it is not acknowledged within this time period, then it is going to uh, retry the message, and then we can define that okay, how many retries you want to make. And then once you exhaust all your retries, then message go to your dead letter queue for the further processing. So that's how it has been used. And if you see the retention policy, as you have seen that, okay, once we get a message from the publisher, we put it into the storage. In the storage, you can mention that, okay, how long you want to store the message. So this is maximum 7 days you can put it in the storage. If not, you lost the message. Otherwise, you can go and process it and then follow this acknowledgement deadline rule. So this is where you create a subscription, and when you create a subscription, it is always you attach to the queue, which queue your subscription is created. The other part is regarding your identification. This is where you're going to create your role. If you look at here, you will have the service account. you would be creating the service account when you wanted to access it. And then when you go for creating service account, it will ask you that, okay, what is the name of service account and all the stuff. And then once you enter service account, it gives you the option to key. So whether you can bring your own key or it will create its own key. And this key is very crucial when we are trying to access this service then, because it has got that public and private certificate information and all the project related information, which project, and then what is your role. So that information it will have it. So yes, yeah, just wanted to see here. So if you see, this is the key. I can delete, I'll create one more key. Uh, And then last point here is about the role. When you try to add role, there are pre-existing roles are there. If you see here, when any user at top, if I wanted to make sure that, okay, I wanted to use the pub sub, so I can just talk pub sub. It will give whether I'm administration, or I wanted to just publish the message. So I can add this existing role. If I want to subscribe the message, I can add subscriber role. Uh, in this case, I've created a user which has got both the role. It can, if you look at here, my user has both publisher and subscriber role I've created. So I can do the both operation over here. With that, let me go to the application. So this is the application right now, which I have the two part of it. One is publisher and one is subscriber. So what I'm doing, this is a simple listener. I'm going to call and put a message. Then once I put the message, right now I haven't created a connector, but I'm going to invoke a Java class, which has also have this Google library for Java. So I've been using that. So this library, if you look at my pom.xml, you will find that, okay, I have added that dependency. So we just need to add one dependency, this dependency, that will make sure that, okay,
Pradeep.
we can communicate with your Google infrastructure.
Hey, Pradeep.
So I have the publisher here, which is going to take this input and then send this message using the HTTP to uh, my topic. So what I'm going that, okay, I'm going important part I need to send it is my project ID, what are the file name. This is the file name is nothing but the JSON key, which we created
Hey, Pradeep,
during
can you
while
hear
we
me?
created service account. So if you look at here, this is structure of this JSON key, which has got public, private key, and all authorization URL and everything. It goes back and forth. That dance and make sure that, okay, we have that. Uh, so once I have that, just this, I'm just making that, okay, my Google credentials here, and I'm building the message and sending the message on the
Hey, Pradeep,
publishing
can
the
you hear
message.
me?
Yes, Mike.
Hey, sorry, I think are you on the different screen because we still see your Google Cloud Platform screen.
Oh, I'm sorry. I'm sorry. Okay,
Yeah,
oh
maybe
let
on the different desktop.
let me go back. Let me share.
Yeah. Uh,
Oh, can you see here?
yeah, now I can see the studio.
Oh,
So
I'm sorry about that. Yeah.
no, that's fine. Okay.
So I was talking about the key. This is the key, which is we're talking about, which is required when you are making
Yeah.
the call to your.
Maybe you can restart when you switched from GCP to Studio.
Yeah.
Maybe
So
last few
let me.
minutes.
Yes. Yes. Yeah. So let me restart back. So this is the
Yeah,
Google.
thanks.
This is the project I have here for the GCP, and this is the our mule configuration. What I'm doing is. This is the listener, and I'm invoking this static method because I can come up with the connector, and instead of Java class I can wrap it inside the connector and we can invoke this connector. So this static class I'm invoking, if you look at this one, this static class. It has got the project ID, file name, and the topic ID, and it's the payload, right? So when I wanted to make the call to Google Cloud, so I need to make sure that I build the credentials using my JSON file, which I talked about. So this is the JSON file which has got private and public key, and we can make the call. And then later on, what it does that okay, it is publishes the message on the uh, topic using this payload. In a similar way, I have a subscriber. This subscriber is subscribing to the one of the subscription, and then it receives the message in a similar fashion. So just to give an let me start this application. Let me make sure that okay, my application is running, and we can just have a quick demo about. So for subscriber, I have this scheduler here. So it periodically goes every 1 minute and see that okay, is there a message? If it is there, it will invoke that message. So let me just send a message, last name, okay, on my endpoint. If you see here, so I have put some logger statement here. That coding is started, message is sent with this key, and then this message is received over here by my subscriber. So that's how we call this endpoint, put the message using this publisher, and then we go here, and then the scheduler goes and pull the message from the subscriber. So let me give the another variation that okay, let me stop my flow so that we are not consuming this message. So in this case, now we are just going to publish the message, but message would not be consumed by this one. And we can see this message in the Google console then, so that okay, let's go ahead and publish a couple of messages. This is successful. Let's go ahead to now. If you move back to Google subscriber, let's go to the topic. Have this topic. So let's go back here and then oh, so it is similar topic. We put a lot of messages. This is in this rollback. Let's go back and try to consume this message over here. So let me start my thing. So with this, we will able to consume all the messages. Oops. Yeah, if you see, so this started consuming our messages then. So I think that okay, we have completed our demo. I would like to thank you everyone for being the attending this demo, and then we are open for the Q&A.
Hey, thank
I'll
you.
stop. Yeah.
Okay, thanks. I think we are very close to the time too, so let's quickly go over the questions. It was definitely long with a content, lot of content filled session. So we covered a lot of things. Thank you very much. So quick questions. First thing, for using caching, right? When you talked about caching, that would require using the object store v2, correct? if
Right.
if i'm if i'm on the cloud, and if I don't have access to object store v2 because it requires subscription, what other things you suggest or recommend that could be used for caching part of it? Is there any?
So well, so the caching, right? There are multiple solutions are available. First, we need to find out what are your needs. Needs in terms of what you want to support, right? So because if your need is you wanted to make sure that okay, your data in the rest is encrypted. So is my caching solution offers that encryption of the data? Do I need the persistent caching or do I need only the in-memory caching? That's another criteria. So there could be the another criteria could be what are the functions I'm looking from my caching, right? Because many times you put the data on the cache and you want to have the searching capability. So does that
Mm,
provide? Or you might be requiring for sorting capability. Does my caching provides that? So depending upon the use case, there are multiple providers are there. You can use Redis cache as well. That's so.
mm,
Otherwise, Google offers the memcache. That's the one thing. If you have this the MuleSoft cloud, then you can have object store too. Uh, so
okay.
and there is other implementation kind of a Hazelcast. They also have the implementation of the caching. So
Yeah.
those are the couple of the solutions or vendors you can use it depending upon your requirement.
Okay, let's go. Thanks. uh, how to find single point of failure in the application network? Do
Well, that's really good question. It's suppose in the MuleSoft, right? You have this the anypoint platform offering, and they have anypoint monitoring as well. So that along with our visualizer will give you the idea that okay, what are the point, right? Where it gives the ability of traceability of your transaction as well. And I think that will help us to find out that okay, which application is bottleneck, and then you need to drill down more and try to find out that okay, which particular component is having the problem. So that's the approach if you have this monitoring tool available. But if not, you are on prem and then you are facing this problem. So how to find the bottleneck? So you need to have some kind of APM tool, right? Maybe it could
mm,
be New Relic or App Dynamic, wherein you can monitor your CPU usage or your memory usage, and then that will lead us to find out how to find out that particular problem. Then.
yeah, no, that's interesting. And I think a few weeks back we had another session on our online group, which was troubleshooting, how to troubleshoot your production issues and all that. Maybe that could be of help for people. Go back and take a look at it, and it is pretty much baseline on what Pradeep was mentioning. It has some troubleshooting tricks in there. It's good. Thanks. Lex is how trigger events will work in GCP. Like until all subscribers receive the messages, will they be persisted?
So this for the events, right? As we have seen that, okay, there is an acknowledgement period. Once that acknowledge your message is delivered to the subscriber, and he or she doesn't react within that time frame, then it will retry the message, and you can define that, okay, how many times you want to retry. Once it exhausts that time, then it will retrieve that message from your storage and put it into today later queue. So at that point of time, it is not going to repeat it again and again then. So there you need to have come up with some another logic wherein you can pick up the message from the day later queue, and then you can start processing again. I
Okay.
hope that answer your question.
Yeah, and I think then based on that, we can set any point. The messages are always like persisted on the GCP side, as long as they are not like completely consumed by client. Is that correct?
It's right. I mean, by default, it persists the message, all the messages,
Okay.
because in the first step, when your publisher push the message on the topic,
Mm.
first thing it does, it write to a persistent storage, and there is an algorithm behind that, because since it is a cloud-based offering and it is cluster-based, so it will make sure that, okay, it will write. Suppose we have the 4 cluster, so it will make sure that, okay, it is right to at least 2 node then, right? Because it could
Yeah.
happen that, okay, you write on one node and just confirm to your client, and what happened that one node is down then.
Right.
So it should make sure that there is algorithm behind that. It will make sure that, okay, it write the message to number of nodes, and then confirm back to the publisher that, okay, your message is successfully received. And then the other part is the consumption of message from that persistent layer then.
Yeah. That's good. Thanks. So the other one is, can GCP be used in on-prem if I have on-prem? I,
Um, I think this is only the cloud only offering. Uh, so I think that, okay,
um,
you cannot, as per as I know that, okay, you cannot use it.
yeah. So which part of it cannot be used? I think if I'm running a MuleSoft, my app is running on-prem, like Mule is running on-prem. I can I should still be able to connect to GCP from my on-prem Mule application, as long as I have all the connectivity established and allowed, right? Like I don't think
Yes,
it
yes.
it, it would mean running GCP on-prem. It would be more like an our Mule app running on-prem. It can connect to GCP from anywhere.
Yeah, yeah. You're absolutely right. Yeah.
Yeah.
So
Uh,
as long as you don't want that GCP pops up on your on data center, right? As
Yeah,
long as it
that's
stays in
different.
the cloud, you can connect it from the cloud, or you can connect it from your data center or your
No, that's
on-prem
true.
Mule application.
Like running GCP on-prem would be a completely different topic
Yeah,
and different
exactly.
things. Right. Okay.
Mhm.
We are 4 minutes over our 12 to 1 1. So, and there are a few more questions. I don't know if we will get enough time to go over everything, but we can take few. And for rest of the questions, what I will do is I will grab all those questions, make a list, send it to you, Pradeep, and maybe we can put those question answers back on this channel in the comments, so you guys can go back and take a look at those, or I can even put them on our meetup site also,
Sure, sure,
right?
Mandeep.
I think then that's pretty much of it, guys. Sorry, we went like 5 minutes over, but that was a very helpful session, Pradeep, and it was full of content. Thank you very much, guys. Yes, this video is always recorded. Any of our sessions are always recorded automatically, and you can go back to our Virtual Muleys YouTube channel, and you can find all our previous videos there, as well as the new one, today's one. Within next few minutes, you should see the recording available on the same channel. So you can always go back and look at all the sessions on the Virtual Muleys channel. And I will grab all the comments, questions, send it to Pradeep. We'll get back to you with your question and answers. Thank you very much, Pradeep.
Thank you. Thank you, everyone. Thank you,
Yeah.
Manik.
Thank you, everyone. Stay safe. Stay well. Thanks.